Alright, so System 7 board set came in, and this board set is having some random reset issues. I have no clue what that is. But as you can see, we are all completely original. And as I've said in past videos here, these headers are all round pin headers. As you can see there on the power input, it's way past the end of its life. But each one of these headers is going to be pulled from the board and replaced with brand new square pin headers here. So we've got a good solid connection everywhere. And as you can see, we've got the old white, these are actually RN, but we've got old single wipe sockets that are in place here on the board. So those are all going to be pulled off, and we'll get some new sockets on there. The filter capacitor, obviously, yes, it's filtered through the power supply here, but it's also filtered through to the MPU and over here onto the driver board. So those need to be swapped out as well. 40 pin interconnect has got to go. That's we'll go ahead and check the driver board for everything. More than likely it's just going to be, all the headers, the 40 pin interconnect, and then also the capacitor there. But the power supply, we're going to go ahead and totally recap this here and get some new headers on here. It looks like the GI headers were replaced there at one point. But just wanted to give a quick overview before I jump into this as far as what I do to all of these boards that come in, before even testing it, just because there's no sense. I'm going to do all this work to it anyways, whether it, and another thing is I actually heard that, somebody was saying that I replace unnecessary parts on these boards, which, I mean, it cracks me up to hear that. It's not unnecessary parts, and, I really wish they were, because, at that point I wouldn't have to stock, each one of these parts here. Excuse all the mess there, but I wouldn't have to stock all those parts if they weren't necessary parts. As anybody knows that deals in pinball, especially putting these games out on location, is that connections are everything. And if you don't have a good connection to your game, you're not going to have a reliable game. And so that's what I do. And since a board repair is not only fix what issue is on the board, which obviously is a must, but I also want to go through and make sure that the boards have the best chance at reliability whenever they leave my bench here for the customer. So I'm going to go ahead and get these put onto my bench and get started on them. Okay, so here are the boards back onto the bench. So we went ahead and replaced the sockets for the CPU and all four of the game ROMs. Replaced all 0.156 headers here on the board, so those are all now square pin headers. Replaced the filter capacitor as well as the crystal, and this game came in with having some lockups there. And what I have found is that the 6808 that was on the board was getting abnormally hot. So I actually I don't have a infrared thermometer or a thermal camera. I couldn't think of what I was wanting to say. But what I did is I actually used my kid's thermometer, which is a surface temp, and I was getting a reading of about 20 degrees hotter with the 6808 versus the new 6802 that I've got on the board, which I have not come into any lockups, and I'm not getting any abnormally hot temperatures coming off this CPU either. But moving on, we went ahead and replaced both the male and female 40 pin interconnect, added a blinking indicator here to the MPU, replaced all 0.156 headers here on the driver board, so those are all new. and then also replaced the filter capacitor. And I'll roll in a picture here. But we had row 6 was locking on. I at first thought it was the 2N6427, but what it ended up being was the 2N6122. So that's been swapped out with a TIP31C, which is the equivalent replacement there for that. So I will go ahead and get this powered up. And as you can see, we got high score to date, last game played, blinking indicator there, and lamp matrix dancing. And the only coil that is on is the coin lockout. And we'll go ahead and get this thing switched into test. So first test, we're just going to cycle through all the displays. Those are all working. And next test is going to be sound test. So no audible sound, but we do get to see the sound outputs. And those are all working. And moving into lamp test, all lamps are working, none are locking on. And solenoid test. So these all go in order as far as how they're placed here on the board itself, which was a design that Chris Hibbler and Victor, aka Dumbass, had came up with, which is really nice. And the special solenoids, these are all computer driven as well as being switch controlled, and both of those, or both functions, are working there. And so switch test, we're just going through testing both rows and columns, going diagonally through the switch matrix. And the last switch that is in Pharaoh is switch 44, and we'll go ahead and test rows 6, 7, and 8, if I can bend my fingers. And there we are 100% good to go. And we'll just cycle through the rest of the audits and adjustments. And we got a full reset there. So there we are. Thank you so much. Here's the power supply, and the GI header had already been replaced, but we went ahead and replaced all the other 0.156 headers here on the board. We've got a new filter cap here for the 5 volts. We've got new filter caps here for the displays. We've got a 330 UF, a 100 UF, 100 volt, 1000 UF, 25 volt, 100 UF 25 volt, and a 47 UF 63 volt capacitor here as well that's been swapped out. And I will go ahead and get this thing powered up, and we will grab some voltages here. So first one, we're going to start with the displays, and I'm going to actually move this so I can get both into camera view. So this is 5 volts. Nope. Sorry, we don't have the power supply connected. But there we go. Alright, so this is going to be 5 volts here. And we're going to have our positive high voltage. And then negative high voltage. And then the other is ground. And then we've got our negative 12. Our positive 12, and then 5 volts again, and then we've got a string of 5 volts down here. So there we are, 100%. Thank you so much for sending them.